Okay, I'm going to go through the review here. I'm going to try and show as much detail as possible. Starting with number 1, negative 8, a to the 10th power, y to the 16th power, over 20, a to the 18th, y to the 12th. All right, so what we notice here is that there's multiplication between everything on top, multiplication between everything on the bottom, which means I can basically separate each of these and then reduce. So I'm going to look at the A's, or the numbers out front, the A's, and then the Y's separately. So first of all, what is negative 8 over 20? Well, what number goes into both of these? I can get a 4 to go into both. So 4 goes into 8 twice, so I have a negative 2. 4 goes into 25 times, so that's going to become a negative 2/5. The a to the 10th over the a to the 18th, using properties of exponents, this is a to the 10 minus 18, which is a to the negative 8, which is the same as 1 over a to the 8th, which means I'm going to be left with an a to the 8th in the denominator. Then the y to the 16th over y to the 12th equals y to the 16 minus 12, which is y to the 4th, which means I'll be left with y to the 4th on top. All right, so now I'm going to rewrite my answer. I have a negative 2 on top. That comes from here. I also had a y to the 4th on top. And then on the bottom, I had the 5. And I had that a to the 8th that came from this right here. So that is my simplified rational expression. Okay, number 2. Number 2, we're given x over x squared minus 6x. And since I have subtraction between these two, I cannot just start canceling x's out. What I need to do is try and factor the bottom so that I can get multiplication and then start reducing. So I have x on top, cannot do anything with that, but on the bottom I have a GCF, greatest common factor of x. I pull that x out, I'm left with x minus 6. And now what I can do is figure out what x over x is. Well, anything divided by itself is 1. So we're going to be left with a 1 on top, and then of course a 1 here when these cancel, but I don't need to write the 1 on the bottom. So I'll just be left with 1 over. Then I had x minus 6 down there. I don't need it in parentheses because it's the only expression there, so just leave it. That's it. Okay, number 3. Number 3, we've got b squared minus 21b plus 54 all over b squared minus 3b. Again, because I have subtraction, addition, subtraction, I can't just start canceling things. I have to turn this into multiplication somehow. So I'm going to try and factor the top and bottom. On the top, I have 3 terms. I do not have a GCF, right? So 3 terms. I do some sort of AC method. I'll do that on the side. We're working with the numbers 54 and negative 21. So we start and think of all the factors of 54. So 1 and 54, it's not going to work. 2 and 27, let's see, that won't work. 3 goes in there. 3 goes in there, let's see, 18 times. So that should work. I have a 3 and an 18. I should be able to get a 21 out of that. But I also need them to be a negative 21. So I'm going to make this a negative 3 and a negative 18. Those will multiply to be positive and add up to be negative. All right, so now continuing, what I could do is do b squared. I'm rewriting the top. I rewrite the end, so I'm doing grouping here. Using the 2 numbers I got, negative 3b, negative 18b, and now I come in here with my grouping. Pull a GCF out of the first 2, which is a b. I'm left with b minus 3. I need a b minus 3 over here. So, oh, I forgot to put a plus in there. Oops. And then now what I need to do is factor something out of here. So I should be able to get a negative 18 here. And just check it. If I do negative 18 times b, I get this. I get negative 18 times negative 3, I get positive 54, so that works. So I'm left with here b minus 3 and then b minus 18. So that's what the numerator is going to become. Now in the denominator, I have two terms, and I have a GCF of b, so I can just pull a b out. So my top is going to become, we said b minus 3 times b minus 18. And the denominator, I pull a b out, GCF, I get b minus 3 here. Now that I have multiplication right there and right here, I can start canceling things if they match up, which they do. I get my b minus 3's to cancel, which leaves me with b minus 18 on top, and on the bottom b. I cannot cancel these b's because I have subtraction between these two, so I just leave it. It's completely factored, so I can't do anything else. Okay, that's 3. 4. 4, we have 8s cubed minus 27t cubed over 6t minus 4s. Okay, again, because I have subtraction between these, I cannot just start canceling. I need to try and factor these. So the numerator, notice the numerator, 8 is a perfect cube, s cubed is a perfect cube, 27 is a perfect cube, t cubed is a perfect cube. So it looks like I have a difference, right? A difference of cubes. So let me go ahead and try and rewrite 8 s cubed minus 27t cubed as something cubed minus something cubed. So I should have a 2 cubed to get 8, an s, then cube it to get s cubed. A 3 cubed gives me 27, then a t cubed will give me t cubed. So in my formula for difference of cubes, that's my a, that's my b. This turns into a minus b times a squared plus ab plus b squared. For us, that's 2s minus 3t. Now when I square a, I get 4s squared plus, when I multiply these two together, I get 6st. And then when I square 3t, I get plus 9t squared. So that's what the top is. Now on the bottom, okay, on this bottom, it's two terms. I don't have different squares or anything, but I have a GCF. I can pull a 2 out. So here's what we'll have. We'll have the difference of cubes up top, which gave us this. 4s squared plus 6st plus 9t squared. And then on the bottom, pull out a 2, and I'm left with 3t minus 2s. Now we're almost there. We notice here that these two look mighty close to each other. In order for us to be able to cancel them, though, we need to try and see if we can pull a negative 1 out to get them to cancel. And to do that, we need to make sure that they're off by a sign, which meant that if we had a positive 2s here, we need a negative 2s here, which we have. If we have a negative 3t here, we need to have a positive 3t here, which we have. So we will be able to factor out a negative 1. And you can do it on the top or the bottom. I'm just going to pull it out of the top. So if I pull a negative 1 out, I'll be left with a negative 2s plus 3t. So negative 1 came out of the first factor there. Everything else just stays the same. And then over, I still had a 2 here. And now this was my 3t minus 2s. Now these two match exactly. Even though they're not the same order, they match exactly, so I can cancel them. And now it's just a question of what to do with that negative. You can just leave the negative out there, or you can distribute it through, or you can put it down on the 2. Really does not matter. So how about I just distribute it through? I'll just distribute the negative through here. Minus 4s squared minus 6st minus 9t all over. The bottom was a 2. And that is it. Okay, that was number 4. Let's take a look at number 5. For number 5, x squared plus 5xy minus xy minus 5y squared. All of this divided by 3t squared plus 3xy. Did I say t squared? 3x squared minus 60y squared. Okay, on this one, again, we have a bunch of addition subtractions, so we can't start canceling. What I notice is in the numerator, I have 1, 2, 3, 4 terms, so I'm going to try grouping on that. In the denominator, I have 1, 2, 3 terms, and that means I'm going to try AC method on that. So let's do our grouping here, slash it there. If I slash it there, pull a GCF out, I get x. I'm left with x plus 5y. I need this over here to be an x plus 5y. So if I pull a negative y out, I will get that. So that's what top becomes. The bottom, I'm going to have to do that here. The bottom, I'm going to do, let's see, there's no GCF except for 3, so I could pull a 3 out right now. Let me try that first. Makes the numbers a little bit easier to work with. And now on this piece, AC method. So I have negative 20, and I have a 1 because this is really a 1 right in front of the xy. So how about positive 5, negative 4? That should work out. Then I rewrite that x squared, and then on the end here, minus 20y squared. And then I use my two numbers, 5 and negative 4, to recreate 1xy. So because it's an xy, right, I have to put here plus 5xy, then minus 4xy. And then I do grouping on this. Pull an x out here, we're left with x plus 5y. I need x plus 5y here. So I put a negative 4y here. That gives me x plus 5y, x minus 4y. Okay, try to put this all together now. This top became, we said, was this up here. Now that turns into x plus 5y times x minus y. On the bottom, do not forget we had a 3 that we pulled out, 3, and then all this grouping stuff, AC method, turned into that. So x plus 5y, x minus 4y. I have two common factors. They cancel. All that's left is x minus y over, on the bottom, 3 times x minus 4y. And we can't cancel anything because there's subtraction between them. I could distribute the 3 through and get a 3x minus 12y, but I'll just leave it like this. And so could you. All right, number 6. Actually, I'm going to do a quick pause here. Maybe. All right, back to the 6. Okay, for 6, I have, now we're moving into 7.2, so we have multiplication between two rational expressions. So here's the first one over, let's see, 8a plus a squared times a plus 8 over a cubed plus 8. All right, so what I can do is I can start canceling things if there's multiplication between, and I can cancel things if they match up. So what I'm going to do is I'm going to look at this as being 4 separate pieces. I'm going to try and factor each one of those. Now, because we've moved a little bit further into this, may not show as much of the factoring, but I'll point out what it is you're supposed to do. So on the top left, this is a trinomial, so you'll do AC method. Bottom left, you have a GCF here. Bottom right, this is sum cubes. And the top left is prime. There's nothing you can do to that. So when I do AC method on the top left, let's see what we get. Let's see if it works first. I have to get a 4 and a negative 2. Do not think that that's going to work, folks. You cannot come up with two numbers. The only thing that multiplies before are 1 and 4 and 2 and 2. There's no way we're going to get a negative 2 out of that. So that's prime. So I'll leave that one alone. It's prime. And then on the bottom, when I pull a GCF out of this, I can pull an A out. I'll be left with 8 plus A. This top right was prime, and then this turned out to be A cubed plus 2 cubed. And then using the formula, we would get A plus 2, A squared plus 2A plus 4, just like that. I'm sorry, that was a minus right there. That was our formula. Okay, so let's rewrite everything we have. We have the top left, which we said was prime. Nothing happened to it. The bottom left, which turned out to be A times 8 plus A, times, now the top right was A plus 8, and the bottom right was A plus 2, A squared minus 2A plus 4. Now that there's multiplication, I look at this as being this whole thing times this whole thing. We can start canceling if things match up, which they do. Look, A plus 8 and A plus 8 are exactly the same. And then A squared minus 2A plus 4 is exactly A squared minus 2A plus 4. Those cancel. So the only thing left on top is a 1. And on the bottom, we have that A out front, and then we have the A plus 2. So A times A plus 2. You can multiply the A through on the bottom or just leave it. That's it. Okay, number 7. Okay, again, multiplying two rational expressions, we have 1, 2, 3, 4 different things to look at. The top left is a difference of squares. The bottom left, there's multiplication here, so there's nothing to factor. Top left, there's multiplication, there's nothing to factor. The bottom right is going to be, let's see, GCF. We can pull a 2 out of those. So let me rewrite what this is factored. Difference of squares, top left would be 4x plus y, 4x minus y. Bottom left, nothing happened. Top right, nothing happened. And then bottom right, I pulled a 2 out and got a 4x plus y. All right, so let's check this out. We've got multiplication between everything, so we can cancel this right here. And let's see, let's just do that for now, and let me rewrite this. I'm going to put this stuff right here out front. 36x to the 8th, y to the 5th, and we're supposed to multiply that times whatever's left there. So in parentheses, 4x minus y. All over, the only thing on the bottom, I have a 2 and an 8, which is a 16, and then I've got an x cubed, and then I've got a y squared. Now this is somewhat like the first problem that we looked at here today. I have a 36 over 16, I have an x to the 8th over x cubed, I have a y to the 5th over y squared. So the only number that goes into both 36 and 16 is 4. So we're going to have, what, 9, and on the bottom, we're going to have 4. And then x to the 8th over x cubed is x to the 5th. Y to the 5th over y squared is y to the 3rd. And then you have that 4x minus y. And that is it. You could multiply this whole thing through here, but I would just leave it. There's no harm in just leaving it like that. I don't like the way that 4 is. I'm going to put the 4 right in the middle. Looks better. Okay, that's it. Number 8. Ooh, yeah. Now we have division. So in this problem, you have to divide a rational expression by another one. Here we go. like that. So remember with division, right? We're going to convert division to multiplication. To do that, we leave the first rational expression alone. We flip this fraction over and we turn it into multiplication because division is equivalent to multiplication of the reciprocal. There we go. Okay, now we're back to the previous types of problems. We've got 4 things to look at here. Top left, difference squares. Did I say that on the last problem? Let me see. Yeah, I did. Okay, I wasn't sure if I had said difference of squares or not. Difference of squares there. Here we got difference of squares again. Here we have a GCF of 4, and here we have a possible AC method. So again, assuming you could do each of those, top left becomes y plus 4, y minus 4. Bottom becomes y plus 2, y minus 2. Times, factoring a 4 out, top right, you get y minus 2. And then AC method on the bottom, you get y plus 4 times y plus 4 again. And now, since there's multiplication, I can start canceling. I have y plus 4, y plus 4, y minus 2, y minus 2. Nothing else cancels. So I'm left with on top a 4 and then this. So 4, y minus 4. On the bottom, uh-oh, I'm getting a phone call. I'm going to pause it real quick. Check it out. I got voicemail. Complete wasted call here. Or recorder. I don't know how they get my number. All right, back to this. All right, so on the bottom I had a y plus 2, y plus 4. All right. You can leave it like that, or you can multiply it all out. I recommend just leaving it just like that. All right. What's next? Number 9. Number 9. Ooh. 9 minus h squared over 12 minus 23h minus 2h squared divided by something. Now, I'm going to go ahead and flip it now and change it to multiplication just to save myself a little bit of time, but just keep in mind that the way it appears on the review, I have flipped it and changed it. Okay, again, 1, 2, 3, 4 things to look at. Top left, different squares. Bottom left, ooh, there's 3 terms. It's a weird order, but that's an AC method, and I'll work through that one completely. Here's GCF. Let me see. How about a 2 and an h on that? Ooh, this is another GCF. How about an h squared on that? Okay, let's write it down. Uh-oh. Okay, equals. Top left, 3 plus h, 3 minus h. That's difference of squares. Bottom left, I'll work on that in a second. Top right, pull out a 2, pull out an h. Left with an h plus 12. Bottom right, pull out an h squared, left with an h minus 3. Now, this bottom left, whoa, bottom left, let's work that out. We've got 12 minus 23h minus h squared. Now, I'm going to switch the order because that's the way I normally did it in class. So I want to make sure I put it in descending order. The negative h squared goes out front. I put the plus 12 on the back. Come up with my little x here. These are my 2 numbers. Just like that. So let me see. What am I missing? Oh, I see what I'm missing. Oops. This is a 2. That wasn't making sense. Minus 2h squared. I wrote it down here, 2, but I forgot to put it over here. So negative 2. So that makes a huge difference because this is now negative 24. So what 2 numbers do that? How about negative 24 and positive 1? All right. Go ahead and put down your 2 n's. And then in the middle, I use my two numbers, negative 24h plus 1h, or just h. Cut this thing off in the back. Let's pull out a negative 2h here, GCF. Be left with h plus 12. Over here, I need an h plus 12. Hey, I already kind of have that up there, don't I? So to get that back, I need to put something out here. So how about a 1? That leaves me with h plus 12, and then negative 2h plus 1. All right, we're looking good here. Now, come back over here and let's insert that. H plus 12, negative 2h plus 1. All right, let's try and cancel here. I see an exact match here. I've got an h plus 12, h plus 12. I also notice here I've got an h over h squared. That's going to cancel out. That's going to cancel. I'm going to have 1h left on the bottom. I also notice that h minus 3 is off by a sign with 3 minus h, right? They're off by a sign. So if I pull a negative 1 out of the top here, these two will cancel each other out because this one's going to become a negative 3 plus h, and they'll match exactly. So I'm doing kind of all that in one step here. I'm left with a negative 1 on top, a 3 plus h on top. On the bottom, I have the negative 2h plus 1, and then I have that h right there. And I can just box that up like that. Kind of ugly. You know, it's so ugly that I think I'm actually going to distribute that negative 1 through the top. I think I'm going to distribute this h through the bottom, just for fun. Plus h. How about that? That's a little better. All right, that's number 9. How about number 10? Now, number 10 through 15, I did in class, but I'm going to do them here anyway because there's a lot of work involved here. Okay, first one, 2a squared b. Now we're moving into addition and subtraction of rational expressions. So when we get to addition and subtraction, this is the hardest part because we actually have to have common denominators before we can add together. And this first one, I have two rational expressions. Let me try and simplify them first. So just look at them by themselves first. By themselves, they each have just multiplication. So I can start canceling things if possible. Here I have an a squared and an a. That'll leave me with just one a on top. I have b on top and a b cubed on the bottom. That'll leave me with a 1 on top and a b squared on the bottom. And then the 2 and the 5, nothing can happen. So that's just simplifying that first one. On the second one, 3 and 10 don't simplify. I only have an a to the 4th on the bottom, but I have a b here and a b squared. That'll leave me with a b on the bottom. So 3 over 10 a to the 4th b. Okay, so now I've simplified the fractions first, the rational expressions, the left one, the right one. Now let me try and get a common denominator. So what I do is I look at both denominators, try and come up with something that is the same. Okay, so let's look at the 5 and the 10 first. 5 and 10. Common multiple of both of those. The least common multiple I can find is 10. So 10. Then let's look at a's. I don't have any a's here, but I have 4 a's here. So that means my common denominator is going to need to have 4 a's, 4 factors of a. And then this has 2 factors of b and 1 factor of b. That means I need 2 factors of b. So what I need to do is make both denominators turn into a 10 a to the 4th b squared. To do that, here's what I'll do. Oh, why did it erase that? Gee. I'm like wiping out my whole problem here. I think that was a 10, all right? Okay, so I need to turn everything into this here. So what I do is on the left side here, I'm going to multiply by something on the top and the bottom. To turn a 5 into a 10, I'm going to multiply by 2. I need a b squared. I have a b squared, but I also need an a to the 4th, right? I need an a to the 4th there. So I'm going to have to put an a to the 4th here. So if I multiply this times this, I should get my common denominator. But what I do at the bottom, I must do the top. Now, on this one, I already have a 10, so I don't need to multiply anything by 10. I have an a to the 4th. I need an a to the 4th, so I don't need that. I have a b, but I need a b squared, so I need to multiply by b over b. Now, if I multiply this times this, I should get this, which I do. Now, before we can add these together, I need to multiply the tops together. So I need to multiply those, and then multiply those. So when I multiply 2a to the 4th times 2a, I get 4a to the 5th. When I multiply 3 times b, I get 3b. Now, each of those are over our common denominator, which we already said was 10a to the 4th b squared, and then this one was also 10a to the 4th b squared, and I had plus between them. So what I'm going to do now is I'm going to take this, going to add to it this, and then push the fractions together. So I get 4a to the 5th plus 3b over my common denominator, which was 10a to the 4th b squared. And that is it. We are done. Lots of work. Break. All right, plugging away here, plugging away. Where are we? Number 11. Let's start a new page. For C over C plus 4 minus 1 over C. All right, so when we look at this, again, we have two fractions. There's nothing I can do to simplify them individually. Like here, I have addition between things on the bottom, so I can't really put those together. Here, 1 over C I can't touch. So my only choice is try and find a denominator that will match for both of them. Now, anytime you see two terms here, or three, throw it in parentheses, and just look at it and say, okay, look, this one has a C plus 4 in it. This one does not have a C plus 4. So what I need to do is put a C plus 4 here. If I do that on the bottom, I have to do that on the top. So now they both have a C plus 4, so I'm happy with that. But the one on the right has a C, the one on the left does not have a C. So I need to put a C there. Whatever I do at the bottom, I do at the top. And that's multiplication here. Okay, so now they both have a C. They both have a C plus 4. So we have a common denominator. Now what I'll do is I'll multiply out the numerators here and here, and then I'll try and put them together. So multiplying C times 4C, we get 4C squared over that common denominator, C times C plus 4, minus, now 1 times C plus 4 is just C plus 4. 1 times anything is itself, over, or I should say 1 times anything is that anything, then over the C times C plus 4. Now that they have the exact same denominators, all I have to do is take this, and be careful here, subtract this. Now what happens is this, and this is where students get in trouble. I take my 4C squared. Now, when I subtract C, I get minus C. And then I have to say subtract positive 4, which makes it a negative 4. So you're actually distributing that negative through the entire numerator on the right side. And then over my common, C plus 4, C times C plus 4. And now what I'll do, let me see. Wow. Is there anything else to do? Well, what I can do is look at this and say, hey, that's got 3 terms. Maybe it factors AC method. I have to address this. I have negative 16 up here, and I have negative 1 here. If I look at negative 16 and negative 1, I ask myself, what two numbers multiply to be negative 16 add up to be negative 1? The answer is there is none, so this is prime. So I'm going to be done here. Just leave this as the answer. Okay, I just got a knock on my door, so hold on a second. All right, where am I at? 12. Okay, for 12, we've got x over x squared minus 5x plus 6 plus 2 over x minus 3. So we have different denominators, so we can't just add these. So before I go try and get a GCF, or greatest common denominator, Least common denominator, I'm sorry. I just got distracted. I'm going to notice that this is a trinomial, so I'm going to factor it. I'm not going to show that work, but it turns into x minus 2 times x minus 3. And I'm just going to forget that that was even there. And now what I say is, all right, I've got an x minus 3 here, and I've got an x minus 3 here, so I'm happy about that. But I need to try and get an x minus 2 in both. So what I need to do is introduce that x minus 2 over here. So I go ahead and put that in, parentheses. Because there's two terms, I will put parentheses. Everywhere I see two terms, I think I'm going to come put parentheses. So that should take care of it. So here's where I'm at. I've got x over x minus 2 times x minus 3 plus 2 times x minus 2 over x minus 3 times x minus 2. Now what I'll do is I'll put together the tops. Well, this one I don't do anything with, but this here I'm going to multiply through. So this becomes my x over, I don't feel like writing that again, so I'm just going to put LCD. This is what I mean. That's my LCD. Okay, plus my distribute my 2 through, 2x minus 4 over my LCD again. So now I will add these together. So what I'm going to do is I'm going to take this x, I'm going to add to it, so I'm not going to change any signs. I'm going to add 2x, and then I'm going to add negative 4, which is just minus 4. All over my LCD. In the numerator, I will collect like terms. So these two put together. Wow, this thing is acting weird. 3x minus 4 is what I have. And then my LCD, I'm done, so I'm going to go ahead and write down what my LCD was. It was x minus 3 times x minus 2. And finish it up. Okay, that's 12. Let's go to 13. Dreams, tell myself it's not as hard. All right, with this problem, again, we have two different rational expressions. They don't have the same denominator. So I'm going to try and go ahead and force a common denominator here. I have an x minus 2 here. I do not have one here, so I'm going to put it in there. On the other one, I have an x plus 3. I don't have one over here, so I'm going to force it in on top and bottom, just like that. Now, I'm also going to put everything in parentheses, everything that has two terms. So let's get my x minus 2 here. I'm going to introduce it over here, x minus 2, x minus 2. Over here, I wanted an x plus 3. Do it on top and bottom. And now I'm going to start putting the numerators together. So I'm going to go ahead and multiply this 3 through the parentheses. That's why it was so important to put it in parentheses. I will be left with, let's see, a 3x plus 9 over my LCD. And then over here, I have a 5x minus 10 over my LCD again. This is equal to, because I have plus here, it's just going to be 3x plus 9, and then plus the 5, and then the minus 10. So just write it all out. 3x. You know what? I'm going to actually just do it in my head. 3x plus 5x is 8x. And 9, let's see, minus 10 would give me negative 1. How does it seem? And then on the bottom, my LCD, which is x plus 3 times x minus 2. And that is it. Okay, number 14. Four x plus 2 over x squared plus x minus 12 minus 3x plus 8 all over x squared plus 6x plus 8. All right, so what I'm going to do first is I'm going to look at the denominators. I'm going to factor these out using AC method. So x plus 4, x minus 3. Over here, x plus 2, x plus 4. Forgetting that these were here. And now let's try and see what we've got. I've got an x plus 4 here and an x plus 4 here, so I don't need one. Here I have an x plus 3. I do not have one over here, so I'm going to have to introduce on the top and bottom. On this one, I have an x plus 2. I don't have one here, so I'm going to have to introduce top and bottom there. So let me get that 14 out of there. This is kind of a mess. Maybe I should just rewrite it. Well, let me put them in, then I'll rewrite it. So that x plus 2, I needed that here. I need it up here. And let's wrap that in parentheses there. Over here, the yellow, I needed the x minus 3. Put it here, here. Wrap this one up with parentheses. So my top looks like this. These two, which I will multiply out by doing FOIL, 4x squared plus 2x plus 8x plus 4 over all that crap down there, my LCD, minus over here the same thing, 3x squared minus 9x plus 8x minus 24 all over my LCD. So collect some like terms here. I have like terms there, and I have like terms here. So I'm running out of room. 4x squared, 2 and 8 add up, we get plus 10x plus 4 over my LCD. I subtract from that 3x squared, and this is minus x minus 24 all over my LCD. And now I'm ready to put them together. Pay very careful attention to the negative here. The negative is going to make this a minus. It's going to make this a plus. It's going to make this a plus. So I will have 4x squared plus 10x plus 4. Now minus 3x squared. Then I'll have a plus x, and I'll have a plus 24. All of this over my LCD, which is, let me clean up the top here. 4x squared, take away 3x squared is x squared. 10x and x is 11x. And then 4 and 24 is 28. All over my LCD, I'm going to go ahead and write this down. It was x plus 2, x plus 4, x minus 3. And then, this kind of sucks, but that is 3 terms AC method, and it factors. It actually turns into x plus 4, x plus 7. And then what you see happens is these cancel. So what we get, final answer, we have x plus 7 left on top, and we have those two things on the bottom, x plus 2, x minus 3. All right, I'm running out of time. That's all I could do. 15 I'll do in class, and I won't put anything like 15 on the test unless it's a bonus. All right, hope that helps.